Looks like it. Yeah. All right, we're ready to start. So, Rhode Island, do you guys want to say something or want me to just get started?
Hi. So I already introduced you, or just kind of like the collaboration that we've had. And I let them know that it's a pilot video or webinar, so they'll be ready to provide feedback afterwards if needed.
Perfect, great.
Yeah.
So what I'm going to do today, as you were told, is I'm going to give a webinar on sampling 101, how to find pathogens in food facilities. And it's really focused on part of outbreak investigation. If you go in a facility as part of an outbreak investigation, Salmonella, Listeria, how do you find the organism to help solve an outbreak? The goal is to convert this into small, quick train videos. So ultimately, the idea will be that this is this webinar that we're going to test run here, probably do one more time, record it, and then share it with people, and then people can do refreshers with these quick train videos. The webinar is organized along the same lines of the 7 or so quick train videos that we want to do. So all of your feedback will really help us to sort of improve both this presentation as well as the quick train videos. And you guys really have the practical experience. I really look forward towards, ideas, suggestions, what we may have forgotten, what, we should add, what we should address. So this project is brought to you by the Integrated Food Safety Centers of Excellence. There are 6 of us, and New York is one. These are collaborative efforts between a university and a state health department to really provide regional and national training on key areas. And 2 of New York's priorities have been around whole genome sequencing training and now increasingly on environmental sampling, because our groups have really done a lot of work. New York State Department of Health, David Nicholas is here, has a lot of experience in this area. And my group here at Cornell has really done quite a bit in this area. And these are just where these centers are. I also want to point out there's a Q&A section there, so you can get information off the center webpage if you want to. So here's what we're going to cover today. So these are the sort of 7 outlines. The last one we're actually not going to do. This time is not ready yet, but we're going to focus on the first 6. So it starts from, why are we sampling, some basic setup, what tools you need, how do you actually sample, basic technique, generally, how do you identify sampling sites, and then in some specific, we get into some specifics for Listeria and Salmonella. If you go into a facility because there's a Listeria outbreak, what do you focus on? Where do you sample? What do you need to do? So let's start out with the general sort of, why are we sampling, background of what we're doing, and a little bit of how this will be different from an inspection. So one of the drivers of this webinar, and I think an increased interest in environmental investigations as part of an outbreak, is that we see more outbreaks and see smaller outbreaks, big part due to detected, big part due to whole genome sequencing. And Listeria really shows that to us. Before 97, before we had any subtyping, we would see 1 outbreak every 3 years, but the average outbreak was 70 people. So for the epidemiologists, this was great because we had a lot of patients. We could query, we could questions, we could interview and identify which foods was common to these patients, which could get a really good idea in terms of the food that might be responsible for an outbreak. Today, with whole genome sequencing, we see more outbreaks, about 20 times more outbreaks for Listeria than we did before PFG, but the outbreaks are smaller. The average size, or the mean, I guess it is the median is 4, but that means we have outbreaks with 2 or 3 patients, which is much more difficult to identify the food source simply based on an interview. You have 2 patients, they both say they ate lettuce within 2 months before they get sick. You can't draw a conclusion on that. Even if they both said they went, shopping at your favorite store, doesn't necessarily mean that that store, that location is responsible for it. So it's more and more important to have these environmental investigations to actually determine, is this facility responsible for this outbreak and what went wrong? And that's what we want to prepare you and others for with this webinar and these quick train videos. So as I said, these smaller outbreaks means we have less epi information. We more and more, not that we didn't before, but it becomes more and more important that we have all data. We look at epidemiology, environmental health, and lab data. And identifying these food sources is more and more relies on trace back, trace forward investigations, types of investigations we'll talk about here. So let's make this sort of practical. This is a semi-hypothetical case study. So this is what the type of stuff that happens. You have 3 listeriosis patients and a lab in Rhode Island, a lab in New York says, we have these 3 patients over the last 6 months, and by whole genome sequencing, it looks like they're all infected with the same Listeria monocytogenes strain, subtype, whole genome sequence, whatever they may say that. And your epidemiologists then go out and do interviews, and they find, an interesting pattern that links it to meal delivery services. The first 2 patients both say they got food from meal delivery service X. The third person also used a meal delivery service, but a different meal delivery service. These are all elderly people that got sick over time. When you go back to the meal delivery services, 2 of them use facility A to prep their food, but the facility Y, delivery service Y uses facility B. So it doesn't all point to facility A. You don't really know with these data what's going on. Is this enough to, get serious about facility A, shut them down if we go to the extremes? Or is it maybe some food that came in from a national chain, deli meat that was brought to facility A and B, and the source isn't either facility, but it's a larger processing plant? We don't know. But this is the type of scenario that would then send environmental investigators probably to facility A, maybe even to facility B, and says, let's go in there and see whether we have a Listeria monocytogenes that matches these patients by whole genome sequencing. What we want to prepare you and others as to how do we go into this facility and do a good investigation where we get some isolates so we can solve this mystery, hopefully. And so what will happen sort of behind the scene is obviously whole genome sequencing. And what we see here is our Listeria monocytogenes from these 3 people. Whole genome sequencing basically looks at 3 million ACTs and Gs and makes a decision, are these Listeria the same or really different? In this case, you could see that, person 1 and 2 are the same, they match every ACT. Person 3, there's one difference, which some of you may have heard of. Some people would call it 1 SNP or 1 allele different, which typically someone says, that small difference, that can happen while this Listeria is in the person, infects the person, makes the person sick. Because Listeria replicates and therefore can accumulate small changes. So based on everything, these 3 people probably were infected from the same source. Now, when you go into a facility, collect environmental samples, they will undergo the same procedure. And then we can say, okay, if we found Listeria monocytogenes in facility A, does it match these isolates? And if so, that suggests an important role of facility A in that outbreak, because we got epidemiology, we got lab, which is this, and then we got your environmental investigation. This is also important to understand because if you find a Listeria in a facility A that completely doesn't match, and let's say you find a Listeria in a drain, that typically doesn't mean any regulatory action because Listeria is common, because that whole genome sequencing, that subtyping is what really is what we are interested in. So that then puts us in a different mindset than an inspection. Because if I go to an inspection and find Listeria monocytogenes in a drain, I'm like, is it perfect? No. Is this a serious issue? Probably not. But if I find in an outbreak investigation Listeria monocytogenes in a drain and it matches person 1 and 2, that tells me that Listeria is probably somewhere in that facility. I have a problem, and that facility likely caused this outbreak. So that's why this sort of outbreak investigation is different from your inspection, why you will collect samples where you would not look at necessarily if you do an inspection or don't investigate an outbreak. Which then obviously brings up that, well, but once we find a pathogen, because I sampled the drain, I sampled the floor crack, maybe even sample the raw, material area. So what do? We can't just ignore the fact that we found Listeria monocytogenes. So typically, if you find a pathogen that's not matches the human case, you're still gonna have to do a deep clean. They have to sanitize. They typically either have to engage their own experts or outside experts to re-swab to make sure they dealt with the issue. You might go back and do some repeat sampling to make sure the control measures worked. What exactly you do depends on the pathogen and the location. If you find Listeria monocytogenes in the raw meat area drain, because that raw meat area is like very close to the deli area that you're investigating, it's very different than if you find Listeria monocytogenes on a slicer, on a deli slicer after it's been cleaned and sanitized, right? So the actions have to be sort of relative to the severity of the finding you have. So if you have an initial positive on a food contact surface, you resample more quickly, you take sort of a little bit more aggressive approach if it's a drain somewhere different. The important thing is to realize this tends to not be an easy thing for these facilities. If you have a Listeria that survives in your facility over time, that can be challenging for them to deal with this. So that follow-up is important. In addition to the follow-up to resample, sometimes you may need to do trace back to an upstream source. You might have to find out, well, we found that Listeria there, but does it really live in this deli facility, this restaurant, or is it being introduced from a supplier? And so that's another thing that might be a facility follow-up. It might not just be resampling, but also sort of looking at sources, doing some trace back in that. So when we talk about sampling for Listeria and Salmonella in these outbreak investigations, there's one thing that's really important to understand. And that is that these Listeria and Salmonella can survive in facilities for weeks, months, and years. So sometimes we can have an outbreak where we had cases that occurred 2 or 3 months ago. We can go in a facility and the same Listeria monocytogenes is still hanging around somewhere. And this picture really illustrates that fact and also how we find that fact. So this is a smoked seafood facility that we visited multiple times, and we did DNA fingerprinting. And on the right side, you can see these DNA fingerprints. And you can see that some of them are the same. First, second, third are all the same. To make it easy, we marked them with a star on the left side, and they all have the same name, 1039C. So what you can see here, visit 1, 2, and 3, they were all 6 weeks apart. Every time we come back, we still find the same Listeria monocytogenes in that facility. We find it in drains the first time we visit, the second time we visit, the third time we visit, but we also find it on finished product. So it shows this Listeria survives in this facility, and it's somewhere where it can hop on and get onto the product. And this type of pattern is not just found in processing plants, it's found in retail too. Same idea, we actually did a study on 30 retail delis, where we went in, collected samples over more than 9 months, and looked for Listeria monocytogenes, and then fingerprinted it. In this deli, we marked different fingerprints with different colors, and you can see this deli has the blue Listeria monocytogenes, which is 258-69, but you can really just focus on the color, every time we visited the facility, except for September. In September, they may have just simply flooded that facility with sanitizer or something. And you can see certain spots where we find that blue Listeria show up over and over again. Floor adjacent to drain. Every time we sample, we find that Listeria. Floor wall junction under the 3-basin sink. Every time we go in, more or less, we find it. Then it's gone for a little bit, and then it comes back. Some other sites, cartwheels, squeegee, we find it 5 times. Cold room drain, we find it multiple times. So with these data, we can't really tell you where this Listeria is surviving over time, but we can say in this deli, this one's surviving over at least 9 months. And this is, a deli counter in a supermarket where we sample. So this tells you, you can come in late, you should be able to find this Listeria in most cases. Even if you find it in a drain, it's not that a drain is what caused the outbreak, but that it moved from the drain to the 1-basin sink interior every now and then, and that's where it contaminated product, or it moved to the slicer, for argument's sake. So that's the mindset, and that's what we need to understand when we go in sampling. So where do we find these Listeria and Salmonella survive over time? We've seen a bunch of them survive in floor mats. Thick floor mats, inch thick. The way they clean and sanitize is maybe we spray some foam on it, maybe we submerge it, but that sanitizer doesn't get in the middle of that mat. Put a person back on there, Listeria comes out. We had one facility, we made them throw out all their floor mats, got rid of that Listeria that we found in the plant for 2 years before that. Hollow areas, hollow rollers like this. You can see a small crack in this roller here, which is a conveyor belt. So this would be more for a food processing facility. If Listeria moves in there, it can survive in there because you can't effectively sanitize in there. But when that roller rolls for 6 to 8 hours, there's moisture, the Listeria comes out, gets on that conveyor belt, contaminates food. And this is what the inside of a roller like this would look. How bad does this get? How important is this? We have seen the same Listeria survive for 12 years in a processing plant and cause a case in 98, 88, 12 years later cause an outbreak. This is not just Listeria, Salmonella. Again, processing facility, but I'll show you that we find similar things in restaurant and retail delis. Salmonella, 1998, auto meal, cereal, 209 cases. 10 years later, 28 cases, same Salmonella, survived for 10 years in that facility. So it's that sort of long-term survival. These bugs find what we call niches where they survive, and that's what causes these outbreaks. And our goal is to go in, get samples from these areas, get the Listeria, get the Salmonella, so we can whole genome sequence. So that's why we're doing this. This is sort of the basic mindset. So now let's get into the more practical part. So first of all, if we go in there, what do we need? What do we need to do one of these swabbing excursions as part of an outbreak investigation? And this is one thing, where we really could appreciate your feedback. This is sort of the list that we came up with. Typically, your state will have a sample toolkit or a checklist. You definitely want to compare what we recommend here against that list. Obviously, starting, you need swabs and sponges because that's what you use to collect the samples. We'll talk about those a little bit more. You need to have a sheet to record the sampling sites. You need a pen or maybe two because one always breaks. When you do the recording, you also should record the product that is being processed, sliced on the equipment. Sometimes you might be in there in the middle of production or in the middle of while the deli is operating. So if they sliced certain type of product, certain type of deli meat, keep a note of that. You typically want Sharpies so that you can write on these bags, the sampling bags. You want a camera to take pictures of the sampling sites. What we often use is we use sticky notes. You could stick them to the sample site. So you have sample site number 1, have a picture of that. Sometimes we can take a picture of the sample bag with a number on it next to the site. Different ways of how you can record the sampling sites. Really helpful when you're going to go back for your follow-up. You need to have a container to transport your sampling supplies. You want to have a cooler, cold packs to transport them back to the lab cold. We often bring trash bags with us because that sampling procedure creates some trash. We try to not throw them in the trash bags they have there, particularly gloves, for example, because then people get worried about, or these medically used gloves. So we often bring in our own trash bags and take them out. Shoe covers, often they're not necessary, but depending on the situation, who's watching you, if you want to be careful, you might want to put on shoe covers. You may also want to think about, should you really sample a patient's home and then go to a retail operation to sample there in the same day? Because someone could say, well, maybe you brought the Listeria in. So again, depending on what you do, shoe covers might be helpful. We try to have them with us. You want to try to get a floor plan when you're in there, or even just sketch one out to record the sampling sites. And then what we typically recommend is to not go in by yourself. You have what we call a sampling buddy. So I have a certain second person that helps with this because this can get quite sort of intense, and you want to have someone to hold the sampling bag, so it makes life a lot easier. Some people can do it without it, but that would be our basic recommendation. Let's talk a little bit about the key sampling tools. The majority of sampling we do is with sponges. And we really use two types of sponges. They're what we call sponge on a stick, which you see on the left side. They come in a bag similar to the regular sponge. Sponge on a stick comes without gloves, typically. We use them without gloves, and we show you that. The trick is to keep your fingers above this groove that's on that sponge on a stick, because that's sort of your demarcation line between sterile, don't contaminate, don't touch it with your fingers, and this is what you're gonna touch. Sometimes we use the sponges that are just a regular sponge without the stick. There you need to use these gloves because you need to grab that sponge and use it. And then we have the smaller sort of Q-tips that we also use. Often we organize it in a box like this. We're gonna use different pictures for the videos. Ignore this piece here. And here you can see some of these smaller Q-tip-like sponges that we use. So that's sort of the general prep. Now, in addition to getting your tools together, there's some other prep activities you typically want to do. You know, you want to talk to your lab. We've seen this often is that, you know, you don't want to surprise your lab with 100 sponge samples. So you need to know their capacities, how many samples can they handle. You need to know what types of samples they can handle. We have sometimes experienced that labs don't want to use sponges because they're more labor intensive. When you use the microbiology, for a sponge, you need about 90 milliliters of media. A swab, it's 10. So it takes a lot more work. If you get pushback on the lab, which we have seen on using sponges, that they use swabs, it's easier for us. Talk to them about the importance of using sponges. Sponges allow you to sample large areas. We do 90 to 95% of our sampling with sponges. That communication with the lab, make sure that the lab has ready, they have the right media, they can deal with your samples quickly, and that gives you more rapid turnaround time, will help resolve an outbreak more quickly. So to me, this is part of, you know, this sort of assembling the tools, is getting your lab ready and set up. So now let's talk about the basics of swabbing. What do we do? How do we swab when we go in? And I'm gonna start illustrating this with sort of an example of a site. And you know, sometimes when you go in, you might find sites like this, and we'll talk about why you want to sample floors a little bit later. And then the question becomes, if you have a site like this, where do you sample? You could sample the diamond board here. You could sample some of the tiles, maybe sort of the caulking between the tiles, which is particularly good if, you know, one of the tiles is loose, and you can see some sort of water creeping out on these seals. But my primary goal would always be to sample this seam between the tiles and the diamond board. And typically I actually try to stand on that diamond board, maybe literally hop up and down a little bit, because there typically is moisture under it. It was under this one, and you can see some sort of dirty moisture and water come creeping up if you put some weight on that diamond board. Now the important thing here is you're not sampling a square surface. I think very often when you're in inspection mode, you're like, okay, we're gonna sample 4 by 4 inches, 12 by 12 inches. Here, you're just gonna sample along this seam, and you might sample 2, 3, 4 yards along that seam. So the take-home message here is that classical sampling instructions still call, and this is from the FSIS, for a sample 1 by 1 inch square, sample 12 by 12 inch area. You can find all of these. And you have these great pictures of someone with a little template and a little Q-tip sampling, you know, a certain defined area. This is not how we do investigational sampling here. We're going to throw away the template, both the physical one as well as the one in our brain, which directs us to sample 12 by 12 inches. And we're going to come to these cracks that you can see here. These are the areas we need to sample to find problems. So if you have what I call the 12 by 12 inch mentality, you want to sort of get that out of your brain when you walk into that facility, because you're on a search mission, not on a defined surface area sampling mission. So yeah, just, you know, the contrast between those two, and obviously this is not what we want to do. So the other thing is when you go in and do good sampling, you tend to get dirty. If someone comes back from my sampling team and their pants don't look like this, and these are my pants after going sampling, then they probably didn't work hard enough to find these difficult to reach areas where Listeria or Salmonella can survive. So this is a job where you're gonna get dirty. So let's walk a little bit through the basics. So here's a sort of a series of slides on sampling a drain. So this is obviously a very nice drain, more what you would find in a processing facility, but you know, you might find similar drains in a retail facility or in a meal preparation service. So here's your drain. Here's your regular sponge. You already labeled it as a sample site. You often have gloves attached. You remove these gloves. You put on the gloves. And there's a lot of debate, and then there's really different opinions on this, whether you have your gloves on when you sort of disassemble the drain to get deep inside. In this case, we put the gloves on. There's an argument to be really made for either one of them. But in this case, if we disassemble, we take off the lid, then we have a sort of an insert here. We're gonna take out that insert and get deep inside the drain. There's some small cracks here that we can sample. Most retail drains are not gonna look as clean as this. Sometimes we can sample this. Sometimes we'll run into problems because a lot of these components are actually screwed in here and it's difficult to remove them, but we need to try to get deep into those drains. We can have the backside of the drain cover can sometimes be difficult to clean or not be cleaned. We want to sample that. So we take this drain apart. We then get our sponge, get deep inside. Probably don't want to put your used sponges on the floor. Have your sponge. You want to see that your sponge is dirty. You want to pick up some dirt there and goes back in the bag. You remove the gloves and go. So that's the basic use with the sort of sponge without a stick. Here's our sponge on a stick procedures, which I have a short video that shows you how to use that one. So you have the bag, you rip open the bag, you open the bag, and then you push the stick up because you don't want to stick your hands into the bag. Well, remove the sponge. Now you have the sponge. Now you can sample. When you have to have an equally intense look on your face as Alexa has here. And then you have your bag, you put it back. Now you don't put the stick back in, you put it back and forth, and sooner or later it will break off, and then you just have the sponge in there. You won't want to stick that stick into the bag above and beyond that groove that I showed you, because that's this demarcation line between your sampling area and your handling area. So you've got a few slides, so you've seen this, pull it apart, pull it open, push it out, keep your finger past this line, and when you stick it back in the bag, you only want to stick it in until about here. You don't want to stick it above here because this is an area that you touched with your fingers. Put it back in your bag, you can see the demarcation line is somewhere here. Twist it back and forth, again, see the demarcation line is here, it's outside the bag, back and forth, and it goes, and finally we are happy because we completed this, and then wrap it up and off you go. So these are the two different strategies on the base, on sort of, you know, sort of the tech, how to do this. So summary here, find the places where these pathogens are likely to persist. You know, we're looking at areas that these organisms can survive for weeks after the contamination event happened. Don't just go in and swab flat surfaces. Use pressure, squeeze the sponges into these right and tight places. Look underneath things, turn things over. Go, you know, as deep as you can. You want to find these difficult to clean, difficult to sanitize areas. Don't be afraid to get dirty. And if you go in a facility that has cold rooms, extended cold rooms, be ready to be in there for a while, so dress warmly. You don't want to go into a cold room and, you know, be done with sampling for 3 minutes because you get too cold, and that happens. So that's just the mechanics on swabbing. So next we focus on how do you find sampling sites. And this is more broadly what you're looking for, and then we get into some more specifics for Listeria and Salmonella. So as you select sampling sites, know the pathogen. Know whether you're going in to find Listeria or you're going in to find Salmonella. You're going to look for slightly different areas. You're going to identify these possible niches, these long-term survival places. But, you know, we will give you some lists, we will give you some ideas, but keep your eyes open, look everywhere, look up. Often people forget to look up because you can have a drop ceiling, and you can see some water stains. That means there's something past that drop ceiling. You might have to open up the drop ceiling and see what's happening up there. And I'm just going to give you some slides of what we're looking for. This is sort of a classic. So this is some sort of drainage device, pipe device. But what you really see here is what we call a dead end. So there's water straining from this pan. It goes down here and it directs it towards the drain. But this here's a dead end. However we clean and sanitize, in most cases, we're not going to effectively clean this end here. Great one to take apart to sample the end here, because we've seen places like this where Listeria, Salmonella could survive for months and years, because you think these things are taken apart every week to be cleaned and sanitized. Often they are not. While you're at it, you see this sort of nice crack in this floor. Someone tried to probably replace a floor drain or so and gave up on it. So that's another good area. Obviously, a drain here will be another area. Floor-wall junctures, so that's where the floor meets the wall. Very often there are cracks that go under the wall, often poor caulking, good sample area. Again, sample 4, 5, 6 inches of that. Brushes. Brushes are a great survival spot for bacteria. You have the brushes that sort of insert into, typically it's a plastic. They go in pretty deep. Inside there, pathogens can survive. There's a whole Listeria outbreak linked to cheese, where brushes were used to brush the cheese, and the Listeria survived in the brushes for months. Different types of brushes you might see, soft brushes, hard brushes, always something I'm looking for. And here's the reason why. You know, these brushes are inserted into a block. Even if I submerge that brush in sanitizer, that sanitizer doesn't go to the bottom of this block. But when I use the brush, have brushing action, on the bottom of this drilled hole, the pathogens that survive will come out. Listeria, you can fit thousands of Listeria on the bottom of one of these brushes, these block holes. Should we sample drains? Absolutely. Drain is an easy way to capture the whole room. You're not going to find all sites in a room, but if Listeria is in a room, very often it's going to end up in a drain. In many studies, they're the most frequently positive site for LM. And remember, whole genome sequencing will tell us whether this is just some random Listeria that came in, or whether it indicates that facility is responsible for an outbreak. Remember, many facilities do stuff that would allow bacteria from drains to get onto food contact surface and food. So sometimes it's even that the Listeria survive in the drain, but high pressure hoses, other things that are used in facilities can actually really allow these organisms to come back. So the other important thing to remember when we go in is, in many cases, you need to disassemble things. It's not enough to sample easily accessible surfaces. So we're going to use this example of a slicer to talk about this. So key things to remember, when you go in and you want to sample a slicer, first unplug and turn off the slicer. Typically, I would look at in-house resources. There's someone that knows the equipment, that routinely takes apart the equipment. You might want to search YouTube videos for how to disassemble slicers, which actually shows you, which what we did, is that routine disassembly in facilities is actually, even what they see in these YouTube videos, how to clean and sanitize them, it's partial disassembly at best. So let's say we have our slicer here in a facility that may have been responsible for a Salmonella outbreak. What do we do conceptually? We're going to go in, we're going to take off this part first. Typically, there's a screw that we can take off. We disassemble this. This now gives us access to some more sites. We can see stuff like this, flashings, difficult to clean areas behind here. This one is obviously in fairly pristine condition, but very often we find issues. Here, great sampling spots. This may be where we're going to get out some of these swabs to sample here. We're going to further disassembly. We're going to try to unscrew the blade. Often these screws are not taken apart. You know, here it's just sort of grease, but very often you might see actual food residues there. And we're going to bring out all the other tools to disassemble this. Disassemble the faceplate here, take that one off. We then might find things here. Often we find things in the sort of center where food residues are lodged. We can look at these knobs, sample those. Now we have our slicer plate. Now we take apart the slicer plate, and you can see this is where things get dicey, pardon the pun. And Alexa looks fairly concerned about this sharp slicer plate because this guy back here warned her that it is very sharp. And we disassemble the slicer plate. Now we get access to this area where we often find food residues. And sometimes these things don't get disassembled that far because everyone, just like Alexa, is very afraid of this slicer plate. Now, if you would have searched a YouTube video before we send them out, we would have realized that it's actually a safe plate disassembly tool. So you might go into this area and say, do you have a disassembly tool for your plate where you can disassemble the plate, remove the plate much more easily? So use resources, understand what they may have to help you with this. Now you have this, again, you have access to these sample sites. You can see how in a heavily used slicer you could find food residues there. Underside is often where things get really dicey. You can see a lot of dirt, a lot of residues. You kind of could try to sort of unscrew this here. So really, go, if the slicer is a suspect, go deep in and disassemble it and sample different sites. And this is what it sort of looks like. And obviously you could do further disassembly here if you want to, but really go in and find these hard to reach places. So, important is, find the niches, find the tough to find areas, and go and do some disassembly where needed. Now let's talk a little bit about sampling for Listeria, what specific sites you would look for there. Listeria loves cold and wet. Getting deep inside freezers, spiral freezers, cold rooms, which you often have in retail, is always a good idea because that's where you often find Listeria. It's not always the best to sample the dirtiest spots because sometimes there are a lot of other bacteria. Listeria actually doesn't survive well. Listeria doesn't play well in the sandbox with other bacteria sometimes. They try to be in a cold place where other bacteria don't grow, but they grow well. So, sample the range. You don't want to sample completely clean, completely dirty. You can pick some of those, but sort of these niches where there might not be that many bacteria, but some can be a good area. Retail, often you will find, these are sort of floor wall junctures. You can see this crack here. Often there's moisture. It's a great spot to sample alongside here for a few yards. Floor mats, we already talked about. Sometimes you want to put some pressure on them, flip them over, sample those if they're there. Any sort of metal interfaces where you have these sort of cracks can be good areas to sample. Brushes, we already talked about, good area to sample. Squeegees. You think of them, they're used to clean, so they're probably sanitized. Many squeegees have poor design, so you have, it could be in the handle even, but very often it's in the actual squeegee part. This was a squeegee we found. You can see this one doesn't look like it gets cleaned and sanitized. There's a lot of foam type, permeable material. Sometimes the way the foam is inserted in the handle. Take a close look at squeegees because they can actually be a very good sample site to find Listeria. And surprisingly, Listeria can survive in these squeegees, sometimes for weeks and months. When you look at a deli area that you sample, understand the overall context. You might want to focus on a deli area, but you want to know, where's my raw meat storage area? Where are some of these other areas where I could have Listeria survive in the raw meat area, but it gets moved over to the deli area. It could be the rotisserie chicken area. So to understand context, try to find the walk-in coolers. Again, focus on coolers. Typically there's a cooler somewhere. You go Listeria sampling and it didn't go in the cooler, you didn't do your job. These are the deli cases we are used to. So deli cases is another area I would focus on. You can see they have the different sort of display areas here, different shelves here that people use. And this looks nice, right, when you have this, and here's your slicer. So this is what you might see when you go in. Now, I encourage you to take a close look at these deli cases. Often there's some disassembly. The shelves are taken apart a little bit. Very rarely are these deli cases completely disassembled. If you sample deli case, which you should, you're going to need some disassembly. You may have to identify the maintenance person, the electrician, to help you with this because there are cooling systems in there that are electric. So you want to take apart some of these things. You're going to find these cooling fans. You see maybe not quite well black mold residue here. This obviously didn't get cleaned for weeks or months. This is all inside one of these deli cases once you take apart stuff. Here's a drain. These drains often clog because no one takes them completely apart. Then you have food residues here. And sometimes deep inside you can find treasures like this in these deli cases. So, you know, here's your, again, your cooling systems. So again, deep inside, as much disassembly as you can do on those deli cases to sample is a good idea. Here's some sort of couple pictures from the general what a deli area looks like. So you have your display case, you have some of your slicers here. Understand context. In this one, you see, fire drill.
Yeah.
That's unexpected.
All right.
Yeah, we gotta clear out.
I will clear out. We'll wait for you to come back.
Okay. Yeah. Sorry about that, Martin. We'll be back.
No problem.
You can pause the recording.
Yeah, that's what I'm trying to do.
So I don't know how long it'll take, but
Okay, so we stop and we take a look at sort of what the deli counter area looks like. So again, so you have your slices here, you have your deli counter here. In this one, when you look here, you actually see some of these stoves here, which actually means to do some food prep. There's actually some raw material coming in here. Sometimes you have your chicken, rotisserie chicken area here. So you really got to look around, find out where different spaces are and sample those. Sometimes to go in those back rooms where they have these sinks is a good idea to collect a few samples under those sinks. This will be what we call a one basin sink. This is a nice, probably as clean an area as you get. But often we look at these floor wall junctures here. If they're not nicely tiled like that, good sampling area. Under here where you have moisture accumulating, could be a good sampling area. And then the cold room, as said, always got to go into the cold room. Often you see it, cramped with stuff. Look for condensation. Definitely a time to look at the ceiling. Look for the cooling units. Often they have drip pans that don't get cleaned. That's a good one to sample. And these shelves, you can have great niches here. If some of these shelves have hollow areas, they're not going to be cleaned. Look at the feet. Even the door seals can be good areas to sample. If there's a drain in the cold room, that's like, that's your best bet, is always the cold room drain. So that's another area you want to sample. So spend some time in the cold room. I would not want to walk out of a cold room if you have a Listeria investigation without 2 or 3 samples taken in that cold room, for example. And here you can see sort of, cold room cleanup. You can see what it looks like when you take stuff out. Floor wall juncture, these corners, these things get cleaned maybe every year. So great area. Here's what sometimes the drains look like. So nothing like the drain I showed you first when you take it apart. Again, often these are screwed down. So often you're going to need to either bring a screwdriver, get somebody with a screwdriver to unscrew them. And then, the collection pan here, deep in the drain. And you can see, these do not get cleaned very frequently. So great sampling sites in retail. This just gives you some idea, where we found it. We've done a lot of work, went in a lot of facilities. So our top hits, cold room drain, floor wall juncture, squeegees, floor adjacent to drain, cold room floor, deli drain, standing water, focus on standing water when you see it, etc. And then you can go, down here and get some ideas of these different areas. So high likelihood of finding it in some of these areas. We find it in the slicer knob, we find it on the cutting boards. Cold room racks, deli case, scales. Don't forget the scales. Sometimes they could be a source. Trash cans, etc. So wide range, but the ones I focused on, cold rooms, floors, squeegees, are definitely our top hits. So this is not just, stuff we sort of make up, but we have some very good data supporting that that's where you want to go. And so if we summarize this, here's a sort of list of sites that we would think are high priority, sort of for retail delis, kitchens, etc. Obviously, not always going to have everything. I highlighted the ones that we found specifically important. But so deli case, talked about disassembly. They sometimes annoyed us down to the coils. Disassemble the deli case down to the coils, and those are the freezer coils, the refrigeration coils. Slicer, deli sink interior and exterior, cutting boards, utensils, packaging tables. Look for difficult to clean areas, drains in the deli areas, drain in other close by areas, floor mats, cold storage room, cold room, big one, squeegees, cleaning brushes, and the focus on areas with standing water. If you have standing water, it looks like that's a regular occurrence there. Definitely look into that. If you have potentially, outbreaks linked to other products, where it's like, 5 people ate cheese, 3 people had some other product, it's not deli. Some of the same consideration, find difficult to clean food contact surfaces. It might be slicers, might be knives, display cases, sinks, drains, etc. Garbage container areas, cold storage areas again. So many of the similar areas as before, but just use your common sense and find these areas where Listeria could survive over time. So that's what we had for sampling for Listeria. Now let's finish up with sampling for Salmonella. Much less common that Salmonella persistence, where it survives in a retail environment in a restaurant, is responsible for Salmonella outbreaks. More often, it's like a lapse of procedures, and you guys are very well aware of that. The raw meat is stored above ready to eat, the cooking temperatures aren't right, etc. So if you have a Salmonella outbreak linked to, a restaurant or retail area, you tend to look more for those things first, so for operational issues. But there have been outbreaks where Salmonella survived in these facilities over time. I think it's a little bit counterintuitive because some of us think of, Salmonella contamination means infected animals or food workers or fecal contamination. We definitely know that Salmonella can survive in processing plant environments. Bakeries, dry environments are one, but the other ones are retail delis and similar establishments. There are probably 2 case studies that illustrate that. One of them was an outbreak linked to a restaurant where the lab did find Listeria typhimurium matching the outbreak stain in environmental samples, sewer, cleaning materials, dishwashing area, hand washing sinks, etc. And there they really sort of, moved it or linked it back to the drainage system. So deep inside the drain, and you saw some of these drains in other pictures, which allowed Salmonella to survive. And then, when they did things, it would aerosolize, water droplets would come back out and contaminate product and cause this outbreak. So this specific investigation said, greater consideration should be given to undertaking trained swabbing in an early stage of restaurant and food-related outbreak investigation. So to me, it's like both Listeria and Salmonella, 2 or 3 drains are almost a must-do when you go in and sample. Tools for Salmonella sampling. So in addition to sponges and swabs, you might bring in some other tools if it's linked to a dry facility, if it's linked to a bakery, etc. And these are the tools that one could use. In addition to the sponges, you could use some spatulas, which you obviously want to have sterile. They can get sterile scoops. So that becomes more specialized if it's, as that bakery dry products, which you would go in and collect samples, because 2 reasons. Number one, you can more effectively collect larger numbers of sort of residue that is baked on in certain areas, even the floors, but also equipment, etc. And secondly, sometimes they really don't want moisture in these areas because it actually would facilitate Salmonella growth. So you might want to consider some different tools if you sample for Salmonella in dry facilities. And, obviously these will be, again, sort of sterilized in some of these sterile packs. some sampling sites. We talked about drains. We talked about slicers that have been linked to it. Cutting boards, another one. Tables under the cutting boards, legs, blenders, mixers, hand mixers. Some of these are difficult to clean. Knife racks, it's definitely another one. Exterior of equipment, grills, cartwheels. You do want to definitely look at proximity to the raw meat area, raw chicken area, whether there's something there, whether you have traffic patterns, and that might direct you towards taking some samples there. Again, whole genome sequencing is going to be the answer. If you find a Salmonella enteritidis somewhere in the chicken area, and it's completely different from the one that caused that outbreak, there typically will be limited, consequences of that, because if you have a person or a tool that touches raw chicken, of course you would find some Salmonella there. But that's sort of things I would look for there. Much less experience in that because there are not that many Salmonella outbreak linked to environmental sources. But the slicer disassembly becomes important here. So there's been at least one outbreak, I think, out in the West Coast linked to slicers where Salmonella survive forever. And now you see, when you take apart these slicers, like the pictures we shot, you take off some of those things, you start to see some really dirty surfaces where these slicers just weren't disassembled and Salmonella could survive for weeks or months and cause some of these outbreaks. So again, disassembly may even be more important with Salmonella than with Listeria, but disassembly is part of the game here. Here's some picture on just a faulty drain. If you have these long stretch drains like this, which people call trench drains rather than the short ones, these are high priority areas too, because very often they have cracks where they sort of put into the floor. And those cracks between drain and floor can be great areas. Often you have residual moisture at one area. So take off all these grids, really look in this complete drain system to sample that. Again, both Salmonella applies for both Salmonella and Listeria. So I hope this have given you, a few things to think about, a few ideas of how to approach, your next, when you send out next time to do environmental sampling as part of an outbreak investigation. I hope what I've impressed on you on the big picture is that environmental sampling as part of an outbreak investigation is very different from an inspection. It's a different mindset, it's different tools. The goal here is really to get out, find these organisms for subtyping, whole genome sequencing. The subtyping is going to provide the ultimate answer. And so that means you can focus on things like drains, etc. The sampling should include both food contact and non-food contact surfaces. Drains should always be on the list. Disassembly may be required or is required for some sampling locations. Most samples should be collected using sponges. When you go in, know your pathogen, know what you're looking for, and know what spots you want to look for. So that's what I had. So looking forward to both questions as well as input, what to add, what to take out, what sort of was more distracting than helpful, so that we can fine-tune both this sort of presentation and then our quick train videos.
Thank you, Martin. That was great.